Thank you for an opportunity for me to introduce WiTricity. Um, WiTricity is a company that's based in Boston, spun out of MIT, and we provide wireless charging technology for electric vehicles and various other mobile electric things. Um, can you go to the next slide? Yeah, yeah. We have a lot of stuff packed into 5 minutes. So I just go through them very quickly. Um, can you go? Yeah. So as electric vehicles really taking off around the world, and renewable energy is really picking up, and electrification is like unstoppable across the globe. Especially in China, Europe, and then U.S. and California. So we're trying to cater to this area right now. Okay. And as electric vehicles really proliferate, what happens is that the people who's not really used to plugging in the vehicle all the time at home and various places, it's a cumbersome thing. It's difficult, dirty. Sometimes with the COVID, it's dirty. So WiTricity really provides the wireless charging technology, which takes that issue out. So it automatically, charge. All you have to do is just park the car, and it automatically charges. So it's really great for convenience as well as commercial vehicles and autonomous vehicles as well. The technology itself, was invented by MIT, and also there's a patent portfolio by Qualcomm as well as WiTricity. And it enables wireless charging transfer of high power. SAE standard has defined 3, 7, and 11 kilowatts of power, and you can charge over a little bit of the distance between with a gap between the car and the ground pad, power through materials, and then we have our technology enables dynamic charging, moving charging, and as well as um, charging in a reverse direction, which caters to the V2G requirements. BMW, 2 years ago, has launched the BMW 530e. I don't have time for showing this video, but you can Google and search for BMW 530e wireless charging. It shows how it works. And then recently, we have seen an announcement from Hyundai. GV60 is a car that they announced with the wireless charging coming up in Korea and China in the United States in the next couple of years. And then China's premier Rolls-Royce, Hongqi, also has been announced, and we'll see a number of announcements coming up soon, as well as a number of car makers making a wireless charged EV in the next couple of years. Okay. Not only passenger cars, but we also cater to commercial vehicles, last mile delivery vehicles, higher power, and it really makes everything automated, and takes out the clumsy, cable, takes out the maintenance issue of the cable, and then reduces operational cost for EV fleets. Okay. And our company started with a licensing model of IP licensing. We have over 1,100 patent in our portfolio, as well as the fundamental patents that enables this wireless charging using magnetic resonance. But we're also making products toward passenger vehicles. We're going to have a charger products available in 2023, and then we'll expand to these commercial spaces, public parking lots, taxi queuing, and then we're also making high power charging for buses. There are people who's doing dynamic charging. That's also in our roadmap as well. Okay. Uh, the uh, the charging itself is, the technology itself can be applied to multiple areas. We have licensees that are making wireless chargers for factory automation, automatic guided vehicles, and AMRs, last mile delivery, as I mentioned about, and then e-mobility, e-bikes, e-scooters can be charged wirelessly, and consumer electronics as well. So what we're looking for is, investors and also partners who's looking to leverage this technology to create, mobility as a service, material handling, retail delivery services, and so on, from infrastructure to embedding into a car. And then if people are looking at the smart cities and so on, I think it's a great possibility for us. We're also making application to the Army cohort program that Josh mentioned about earlier. So if you're interested in talking to us, please let me know. And the company based in Watertown, we're expanding very quickly, and we love to find people who's interested in leveraging this technology to, make a seamless automated charging for an expanded EV world. Thank you very much.
Thank you, Tom. You pack in a lot in 5 minutes. That's incredible. Let's open it up to the panel. I think Bob from Diamond Edge Ventures from Mitsubishi has a question.
Sure. So what is your limitations on power? How much can you support? I saw different profiles of scooters, robots, cars.
Sure. So actually, technology works in all kinds of power levels. Consumer electronics, 15 watts, 50 watts. E-scooters and so on are powered at typically like 80 to 200 watts. AGVs are powered at 1 kilowatt, sometimes 3 kilowatts if it's a big one. And then car SA standards has been set such that it supports 3, 7, and 11 for now, and it's expanded to 22. We have people, who's designed buses go up to like 300 kilowatts, and then one of our partners making a 200 kilowatt charging system for EV ships. So the technology can scale really, to a small power to a big power.
Just a follow-up quick question on that. Do you know if you're using for your wireless charging, if you're using GAN on GAN, what is your kind of underlying wireless power management? How are you managing that from a material standpoint, or do you know?
Well, I think right now the GaN is not necessary. We use silicon carbide technology. GaN might be coming into the future, but our current focus is cost reduce, right? Reduce the cost so that it can really scale and enable consumer products as well as commercial deployment. So our focus is on making sure that our charger can be grid compatible with ISO 15118, and OCCP compliant, so that it can be connected to the grid and controlled, and then the lowest cost as much as possible.
Great, thank you.
Go ahead, Mark.
Yeah, hi, Mark Rosinski, General Dynamics Mission Systems. Does your technology require anything to be retrofitted to the vehicles, or is that charging plate or receptacle already part of the vehicle designs?
That's a good question. We have a number of car companies, as I mentioned, like BMW and McLaren, FAW, and also Hyundai. These companies have actually made the product to be embedded into the car, so that it was part of the SOP system, and the charging receiver side basically goes through magnetic resonance and then receives the power into a rectifier and then charges the battery directly. So it's embedded into a car. But we're also making a retrofit system to be announced pretty soon. But Tesla Model 3 we have retrofitted, and we can do a retrofit to a number of commercial vehicles. So we can do two paths. But SOP programs takes a long time, so we're looking for a chance to identify a quick deployment with a commercial target vehicle, and we can retrofit using maybe CCS port or CHAdeMO port into the vehicle.
Hey, thank you.
Okay, just one last question that appeared in the chat. It's from Joseph Fryer from the United States Air Force. He says, this is interesting, but the challenge, I assume, is the infrastructure for the pads needed for charging. Do we see any funding in the recent infrastructure bill that could help your efforts?
Absolutely, that's what we're looking for. And infrastructure bill came up. DOE, is spending a lot of money on EV electrification. We have money coming through, like California, Energy Commission. So we are looking for that potential. So we have a prototype available that we can retrofit into a car. So it requires car company, this funding agencies, and then fleet operators to work together with us. So we are starting that right now. So if you have ideas, interest, please let us know.
Awesome. Tina, you want to ask the last question?
Yeah, quick question. Can you talk a little bit about the competition and in terms of the charging speed right now? How do you compare to the fast charger and so on?
Yeah, so right now, the SAE standard has been set so that it really enables the level 2 charging, AC charging up to 11 kilowatt. But fast charging, like DC charging, 50 kilowatts or 100 kilowatts is available from some companies that we're still working to negotiate on licensing, and we're also making our own charging system. So the key is the technology evolution would allow us to do both the fast charging as well as AC charging, and it's all depending on the use case and the cost and what how it benefits the end user. So that's where we really want to work with people who has great ideas about utilizing wireless charging, so we can talk about the exact fit for such an application.